wanted to give you a second example of decomposing by partial fractions. And so this time I've given you 5 over x squared plus x minus 6. Remember, the big idea here is that your denominator needs to be written as a product, okay? That's the only way you're going to be able to figure out what your common denominator is supposed to be. So you'll factor that common denominator. In this particular case, you're going to have 5 over the quantity x plus 3 times the quantity x minus 2, and then you should be able to go from there. So I'm going to use this moving forward. All right, so what do I have here? I have, basically this should break down as something over one of the terms plus something over the second denominator term. And again, what we're really trying to accomplish here is figuring out that a and b value. These should be constants, okay? You'll have constants in the numerator, you'll have linear denominators is essentially what's going to happen here. Remember, the fast way here is to multiply the numerator and denominator by your common denominator. Common denominators can be the quantity x plus 3 times the quantity x minus 2. So I'm going to scoot this over just a little bit to make this a little bit neater. Okay, so I'm just going to, again, you can find common denominators here, or you can just multiply the numerator by the common denominator. So I'm going to do the second one because it's a little bit faster. So I'll multiply this numerator by the common denominator. I'll multiply this numerator by the common denominator, and I'll multiply this numerator by the common denominator. And take a look at what happens. The whole idea here is to knock out all the denominators. So both of these divide into both of these. This stuff's all gone. We're just left with 5. Over here, the x plus 3 cancels the x plus 3. We're left with a times the quantity x minus 2. Okay, here you can divide an x minus 2 out of the bottom and an x minus 2 out of the top, and we're left with plus b times x plus 3. Okay, we can go through the process here. 5 is equal to, now I like to go ahead and group my terms. I want all my x terms together, I want all my constant terms together. So I'm going to get a times x, I'm going to get a times negative 2, I'm going to get b times x, I'm going to get b times 3. A times x will give me ax. B times x will give me bx. Okay, a times negative 2 is negative 2a. B times 3 will give me plus 3b. Okay, we have x terms, we have constant terms. Okay, notice, it's just equal to a constant term here. There is no x term. Technically, this is 0x plus 5. What that tells me is my two x terms, and this is really x times the quantity a plus b if you want to factor it, I'm supposed to have a 0 coefficient with my x. So that tells me a plus b has to equal 0. All right? Meanwhile, my constant terms need to add up to give me 5. So negative 2a plus 3b needs to add up to give me 5. All right? You can multiply the top equation by 2. 2a plus 2b is equal to 0. Negative 2a plus 3b is equal to 5. If you solve that, you get 5b is equal to 5. Looks like b is going to be equal to 1. If you want to go back, remember a and b need to add up to equal 0. So that means a is going to be equal to negative 1. And you do want to actually write this as a sum of partial fractions in the end. So basically substitute back into this. Let me just clean this up a little bit. My a value here is negative 1, okay? It was supposed to be over x plus 3. And my b value was positive 1, and it was supposed to be over x minus 2. So that is how you could write the original expression using partial fractions. And again, from an algebra standpoint, from a pre-cal standpoint, maybe not all that useful, super useful when you take a calculus.